Hello student, welcome to this video. This is the continuation of the previous lecture, which consists of the lecture from 1 to 8 for the chapters 1 and some part of chapter 2 of the vector analysis by M.R.Spiegel. This series of video is for the student of physics honors and as well as for mathematics it is the important book also for the IIT JAM examination. Okay, that's why we decide to complete the supplementary problem solutions in the several videos, and this is the lecture number 9 or video 9, in which we want to solve the some part of the chapter 2 from question 2.73 to 77. So let's start to question. 2.73 says that the ABCD is a quadrature whose this is a quadrature where P and Q is the midpoint of its diagonal. Prove this relation and the genesis preceding of this problem. Okay, let's draw a quadrature which like that. This is a not equal side. This is like that, and if I draw two diagonal of this is one diagonal and whose midpoint is like here, and the uh, another diagonal is like that. Sorry, somewhere here. Okay, in the pen tab there is a smoothness is problem, so try to understand the problem. Okay. So let's start the name as A, this is B, this is C, and this is T. Okay, and these are the midpoint of AC. This is P and midpoint of Q. Okay, take the position vector of A as the 0, the position vector A as the 0, B position vector of B is B, position vector of C is C, and position vector D is taken as D. So the position vector of P, what is the position vector of P? This is 0 plus C by 2, that means C by 2. Similarly, so the position vector of Q, this is B plus D by 2, this is B plus D by 2. Now if we take the AB square plus BC square plus CD square plus DA square, which is nothing but left hand side. So this is equal to AB square. AB means length is B, so this is B square. BC is nothing but C vector minus B vector, third mod. CD means D vector minus C vector, third mod, and DA square. DA is the length of D square. So this is nothing but B square. This is nothing but B square plus this is C square plus B square minus 2C dot B, and this is nothing but D square plus C square minus 2C dot D, C vector dot D vector. Okay, plus D square. So there is 2 B square, 2 C square, 2 D square minus B dot C. If we take 2 as a whole, so this is B dot C plus C dot D. Okay, in the right hand side there is AC square plus BD square plus 4PQ square. Okay, so this is AC is the C, so this is C square plus BD is the D vector minus B vector square plus 4P square. P is the nothing but B plus D by 2 minus Q is the C by 2, PQ is this square. So this is C square plus D square plus B square minus 2 B dot D plus 4 and 2 square is cancel out, so this is becomes like b plus d mod square plus c square minus 2 b plus d dot c. Okay, so this is nothing but 2 b square plus c square plus d square minus b dot d plus, from here we got b dot d, from here you got b dot d, and from there you got b dot c plus minus c dot d. These two are cancel out and you get left hand side is the right hand side. Left hand side is the right hand side. Clear? So you take the position vector and you got the answer. Very simple. Next is the 2.74 says consist a plane P perpendicular to a given vector A and distance d from the origin. Find the equation of plane and express in the rectangular coordinate system. Okay, consider a plane P. This is a plane P which is perpendicular to a vector. This is the a vector which is perpendicular to a, and distance from P and distance P from the origin. If we take this is the origin, this is the perpendicular distance, this is the perpendicular distance P. Find the equation of the plane. So if we take any point on this plane is the R, this is the any point on this plane R. Okay, so if the unit vector along this is n cap is nothing but the unit vector and this, so this is a vector by a, and if we multiply this n cap with the R, then we got the P. So you can say from the diagram this P is nothing but, P is the perpendicular distance, is nothing but n cap dot R vector. What is the n cap? N cap is the a vector by a dot R cap. So you get the a vector is can be written as ax I cap ax plus j cap ay plus a cap k cap az by a vector. A vector is nothing but the a dot r I cap x plus j cap y plus k cap z. Okay, so if you dot product I1, so this is ax plus y plus z az by a, this is P. So you can say this ax plus y plus z az is nothing but the PA. This is the equation of plane. Equation of the plane. Simple. Next question. 2.75 says that let R1 and R2 the unit vector in the xy plane making an angle alpha and beta with the positive x-axis, okay. So this is x-axis and this is y-axis, okay. And the if we take this as a R1, okay, take this is a R1 and this is a R2. This is R1 and this is a R2. So R1 is with the angle is alpha and this angle is beta, okay, and R1 and R2 is given. No, so sorry, R1 and R2 can be expressed like that because the you say this is the R1 and this is the alpha, so this component is R1 cos alpha and this component will be R1 sin alpha. So you can say this R1 vector is nothing but R1 cos alpha I cap plus R1 sin alpha j cap. Very simple. Similarly you can say R2 is nothing but R2 cos beta I cap plus R2 sin beta j cap. This is a question number A, answer of the problem A. And by computing R1 dot R2, if we want to find out the dot product R1 dot R2, this is nothing but magnitude of R1 magnitude of R2 into angle between them, which is nothing but alpha minus beta. And this R1 dot R2, if we put the R1 dot R2, then I cap 1, j cap 1. So this will be nothing but R1 R2 cos alpha cos beta. Okay, and you know these are the unit vectors, so R1 R2 is 1, so R1 R2 will be 1, this will be 1. Okay, this will be 1, and JJ, which is R1 R2, this is also 1 sin alpha sin beta. So you get cos alpha minus beta is nothing but cos alpha cos beta plus sin alpha sin beta, and this is this proof. And for that cos alpha plus beta, you put just beta is minus beta, that's mean this R2 if along that direction, then we can say beta change to minus beta, then we get cos alpha plus beta is nothing but the minus is for cos of minus beta is cos beta, but sin of minus beta is minus sin beta, that's why this is cos alpha cos beta minus sin alpha sin beta. Okay, and the figure for that, this is a R1 with angle alpha, and this is a R2 with angle beta, this is a minus beta, that's why this becomes like that. Okay, clear, this is the answer. Next question, 2.76. Let A is the position vector given point xy1 x1 y1 z1, and R is the position vector at any point xyz. Describe the locus R if R minus A modulus 3. That's mean you can say this is a x minus x1 whole square plus y minus, just subtract this vector and modulus. So this is y minus y1 whole square plus z minus z1 whole square, which is nothing but the 3 square, that means 3 square. This is the equation of sphere sphere whose center at the x1 y1 z1 and radius is the 3. Okay, next B, R minus A dot A is equal to 0. R minus A dot A, R minus A means x minus x1 I cap plus y minus y1 j cap plus z minus z1 k cap dot x1 I cap plus x2 y1 j cap plus z1 k cap is equal to 0. So you get x1 x minus x1 plus y1 y minus y1 plus z1 z minus z1, this is equal to 0. And sorry, A is given by 1 1. Okay, okay. Actually, this not to be expressed as any physical relation, that's why you can say that just draw the figure. R minus A, if this is R vector, this is a vector, R minus A is that vector, and this is a vector, this is A, this is R minus A. If R minus A and A is perpendicular, this is the angle, 90 degree, this angle is 90 degree. So this represent the plane equation of plane equation perpendicular to a vector. Okay, go to the C where r minus a dot r. In this expression you just minus and dot product with r, then you get x minus x1 plus y minus y1 z minus z1. In this expression there is a benefit because we got x square minus x into x1 plus y square. You just express at x into x1 plus x1 square, so you note x1 square by 4, so you need to minus this portion and of the all portion, so this is a x1 square plus y1 square plus z1 square by 4. So this will be nothing but x minus x1 by 2 whole square plus y minus y1 by 2 whole square plus z minus z1 by 2 whole square equal to x1 square plus y1 square plus z1 square by 4. So this is a sphere equation of sphere. Center is at x1 by 2, y1 by 2, z1 by 2, and the radius is root under x1 square plus y1 square plus z1 square, which is nothing but a by 4 root is 2, which is a by 2. Okay, clear? Next question 2.77. Suppose a vector and b vector are PQ are respectively. Find the equation of the plane passing through Q and perpendicular to line PQ. Find the equation of plane passing through Q. This is a P. This point is P, whose vector is a vector. This is a P. This is a vector, and the another one is B vector. This point is Q. So the plane is, this point is Q. This plane is Q passing through Q and perpendicular to PQ line. So draw, this is a PQ. So the PQ is nothing but Q minus B, that is B minus A. So B minus A is nothing but minus 2 I cap minus 3 j cap minus 6 k cap, which is perpendicular to this plane and passing through Q. So if we take the plane like that, where this is a R, so the vector QR and the PQ is perpendicular, so PQ is perpendicular to PR. If this take point is R, so this is the position vector R. So this vector and PR vector is nothing but R vector minus Q vector. So you can say PQ vector dot R minus Q vector, that is B vector, is equal to 0, and you got to PQ is minus 2 I cap minus 3 j cap minus 6 k cap dot R minus B, that is x minus 1 I cap plus y minus or minus plus 2 j cap and z plus 4 k cap equals to 0. So this will be nothing to x minus 1 3 y plus 2 6 z plus 4, this will be 0, and this is nothing but 2x plus 3y plus 6z minus 28. This is the equation of this equation. This is the equation of the plane. Equation of plane. Okay, go to the next question. Find the distance from the point to the plane. Find the distance from the point to this plane. That's mean this is a plane. We know the plane whose perpendicular direction is PQ is the perpendicular direction. So n cap is nothing but PQ vector by PQ mod, and the point is here, something here, somewhere here. So you need to find out this perpendicular distance. So you perpendicular distance is nothing but the r vector dot n cap. This is the perpendicular distance, and this r vector can be taken as the this point, this r vector, this is the r vector. This r vector can be taken as this is the q point. If you take this q point and this is the origin, the r vector is nothing but the b vector dot n cap. N cap is nothing but pq vector by pq mod. Okay, so do the just dot product, do this just dot product. So we get the p is nothing but b vector dot pq vector by pq vector mod. B vector is nothing but 2 I cap minus 3 j cap minus 5 k cap dot PQ, that is minus 2 I cap minus 3 j cap minus 6 k cap by modulus, that is 2 square 4 9 3 square 16 36. This will be becomes 1 by 7. This will be 7. This is minus 4 plus 9 plus 30. This is nothing but 1 by 7 into 35, which is 5. 35. This is the answer of this question. Okay, thank you for listening. This is all about me, and this is my contact detail. You can contact with me regarding any question of physics. And if you are new in this channel, please subscribe this channel to get the upcoming videos, and press the bell icon to get the notification of the new video uploaded in this channel, and share this video to your friend who needs to the solution of the supplementary problem of the vector analysis by Spiegel. Okay, thank you, take care of you. Thank you, we will meet you in the next video as soon as possible. Thank you.